Now this is on arc length. So we're going to use this idea of radians to figure out how long an arc can be. So like this right here, this S piece is known as arc length. So very similar to radians, right? Because we use that idea of that arc length. But the difference is with radians is we're talking about how this angle, how big that angle is that opens up to that arc. So that this angle is your radian. This piece is known as your arc length. And then this piece is known as your radius of your circle. Okay. So the radian measure theta of an angle is the measure of the ratio of length of the arc. It expands out to the circle. So another way for it to say what I just said, to the length of the radius. So another way to look at radians is it's your arc length divided by your radius, okay? Because it is the ratio of your arc length to the radius. Now, we use for shorthand S for arc length and R for radius. So don't get confused, like that R is not radian, all right? Remember, we don't use a unit for radian. You could write rad, but also your theta is your radian. Now, for a circle of a radius r, a central angle, which means it just comes from the center, you're in standard position, okay, of theta radians, subtends to an arc whose length is s, then we have this formula. And so what that formula is saying is your arc length, let's see if I can spell, equals your radius times your theta, which has to be in radians, okay? There's another formula if you're going to use it in degrees, but so always make sure your theta is in radians. And so this will be helpful when we get into applications. So for example 7, it says you walk 4 miles around a circular lake. So I'm going to give us just a diagram. I'm trying to get better at drawing, so forgive me. And I'm going to totally approximate, okay? Let's just say we start here, and I'm walking and walking and walking, and I walk for 4 miles. So here I am walking. I want to know, give the angle in radians, which represents your final position relative to your starting point, if the radius is 3 miles. So there's my starting point, okay? And I don't know if this is exactly, I don't know if my drawing will be terribly accurate, but let's just say we stop here. I need to figure out what this theta is. Well, we know the radius of our circle is 3 miles. And we also know we walked for 4 miles. So using this formula here, we have arc length, which is 4 miles, equals my radius, which is 3 miles, times we don't know theta. So we isolate theta, we're going to divide both sides by 3 miles. So we end up getting 4/3 is our theta. So let's put that into terms that maybe might stick a little bit better. Well, if we do 4 divided by 3, that's about 1.3 radians, which hopefully sits well with you, because remember that 1 radian was roughly, we haven't figured it out yet, but we will, looks about 60 degrees-ish. So, this looks a little bit bigger, but that's just because I drew it fast. But so your theta here is about, is about 1.3 radians. This is exact. And this is rounded. So now we want to find the degree of this. So bringing it back to what we learned in this unit, we have 4/3 radians. If I want out degrees, I want my degrees to be in my numerator, and I'm going to divide by pi. I'm going to go to my calculator. So 4/3 times 180 divided by pi. So it's 76.39. And does it give us exact where to round to? It says nearest whole degree. So let me just go back. So it looks like I'm going to say 76 degrees. All right, our second example with our arc length, it says how far does the tip of a minute hand of a clock move in 35 minutes if the hand is 6 inches long? So I'm going to stop reading and give myself a clock. And it went 35 minutes. And we know this is 6 inches. Okay, we want to know, what you're looking for is how far did that minute hand travel? So I need how much this green piece is. And so what we can do is, well, there's a couple of different ways to solve this, which is kind of nice. One way is, let's just figure out what the portion is of that circle that the minute hand has traveled along. We know the circumference of the circle is 2 pi r. So for this exact circle, it would be 2 pi times my radius, which is 6. So 12 pi is my entire circumference of that circle. Now, I only want to know the 35 minutes. So what I can do is I can take the entire circumference and multiply it by the fraction of what it's traveled, right? 35 minutes out of the full 60 minutes. And if I do that in my calculator, and it says it wants exact and rounded to the nearest inch. So I'm going to leave that pi alone since it wants exact. And I get 7 pi. So what I did is I did 12 times the 35, and then I divided by that 60. That's exact. Whenever it asks for exact, you want to leave in terms of pi. If I want it now to the nearest inch, I'm going to do 7 times pi. And we get about 21.99. So it's going to be about 22 inches. And in class, we'll talk about maybe there's another way we could solve this.